Hello folks, let's continue with the exercise, not 7.1, we will be taking up the next exercise. And here, like when I was taking 7.1 exercise, I was telling you that every time we will be learning new formulae. So actually in this exercise, we won't be learning any new formulae, but actually it is on the basis of method of substitution. So we'll be using this method of substitution and we will be solving the integrals. It's very interesting. And but only thing in the exam when it comes, this is when we do exercise wise, it's very easy to find out and do it because we know this exercise is based on substitution. It's easy to classify and do it. The entire integration, this is the problem. When it comes in the exam, you should know to classify which type it is following and then do it. Once you know the type, then it's easy to do. So it's substitution here. We'll be always substituting and replacing and doing the problems here. Very, very interesting, this section. So let's start with the exercise 7.2, and I think I should drop and write. Overwriting doesn't look nice. So let me write exercise 7.2. I just skipped my attention. Yeah. And we can start with the first problem. Let's see how it is. The first problem tells that they give you a common instruction that integrate the following. There are 37 questions in this exercise. Each, I don't know vaguely if I could count. Of course, I'm talking about the old textbook, not the new one. In the old textbook, vaguely, I mean, I wouldn't be very precise, but there should be somewhere around 290 problems. Yeah, there is around 290 problems in that exercise 7.2. That's how it is. So that has to be like by the time we finish the chapter, we would have done those many problems. Yeah, so in this exercise itself, there are 37 problems. Let's start right away. Exercise 7.2, the first question. It says that you have to integrate, sorry, 2x over 1 plus x squared dx. So as I told you, this is a method of substitution where you will be substituting a certain thing so as to get the derivative. Now here in the integral, because it is 2x over 1 plus x squared, we haven't learned anything of this kind. So we will be checking the complicated part. We will substitute, and in that process the less complicated part gets replaced. That is the beauty of this substitution. So as I would like to show it directly before just telling it. Let's 2x and 1 plus x squared. 1 plus x squared looks a little more complicated, so let's substitute 1 plus x squared as u, and let's get the derivative du over dx. Derivative of 1 is 0, and derivative of x squared, it is 2x. So if you could take this dx on the other side, your du becomes 2x dx. Look at this, 2x dx. So now what we are going to do is we are going to convert our I. I is no longer in terms of x, it is going to be in terms of u. So how can you replace that? 2x dx can be replaced by du, and 1 plus x squared, officially you have called it as u. So it's du over u. We know 1 over x is, the integral is log. So it's going to be log u. Your integral is going to be log modulus u plus c. So log modulus u means log modulus 1 plus x squared when you revert back. Of course, you cannot keep at u because u is your creation. You have to get back to x. So that's it. So as easy as that. So once we are done with that, we can move to the next problem. They're all going to be substitution, as I know, because we are in this exercise. It's very easy for us to know that it's going to be substitution, but same is not going to happen in the exam. That is a place where you have to use your foresight. So this one, it's log x the whole square over x dx. Again, you have to use your common sense. The more complicated, and it doesn't mean that the complicated function, it will be placed, like it will be embedded. So you have to choose the proper function. Like for example here, log x square. So there is a function log x and there's a square also. We cannot take the whole thing. It will not be of much good to you. So here you have to judiciously choose the function that you have to be substituting. It should be only log x. So let's take that way. So you will get u as log x. If u is log x, when we take the derivative, we all know that log x has derivative 1 over x. So when we make the substitution, it is going to be du, which is dx over x when it goes on the other side. Please take care of this du over x. So how is your I going to convert? I is going to become u squared log u. Sorry, u squared du. I'm very sorry, because log x the whole square becomes u squared and dx over x becomes du. So it's u squared du. Now you go for the integral. So the integral will be u cube over 3 plus c. So u cube for you, it's going to be log modulus x. See here, everything is going to be in modulus, only then your domain will be proper. So that way, that's our integral. Let's go for the third problem. It says that I equal to x plus, yeah, this is pretty tricky. It is x plus x log x. See, actually what happens, many problems, what I find out is that many problems which look subtle and good over here in this exercise, when it moves to in the paper, it will look very complicated, because when everything comes together, it may look complicated. Something that looks very subtle here looks very complicated in the paper. So you have to be very aware of what is being done over here. So it is dx over x plus x log x. This is quite not very organized. So let's organize it by taking the x out. So you will get 1 plus log x. So this is the place from where you have to think of the substitution. X is a pretty simple function and 1 plus log x is another function. So obviously it should be 1 plus log x that you should go for a substitution for. So let's substitute u as 1 plus log x. If that is the case, then your derivative, sorry, du over dx is going to be 1 over x. So that way du is going to be dx over x. So your dx over x can be simply replaced by du. And 1 plus log x of course is u. So you are left with du over u. We know integral of 1 over u is log. So therefore it's going to be log modulus u plus c. Since u is your creation, you have to come back to the function that we started with. It is 1 plus log x. That's about this. I think that should be all for this video. We have many problems here. So maybe with the remaining lot of problems, you can meet in the next video. Thank you.